Hi guys, in this lesson we'll talk about decorators, which are functions that take another function as input, allowing us to modify its behavior. Let's get started. First, let's call a function named square underscore list underscore creator, parentheses. Then let's define it, def square underscore list underscore creator, parentheses, column, new line, and then let's return a list comprehension, return square brackets x double asterisk 2 for x in range parentheses 100,000. Now we want to measure the duration of this function. How can we do that? We can use a function decorator. So now let's import time, and then let's define the function decorator. Def time underscore it, parentheses, and here we are going to pass a function. So func, column, new line, inside create a nested function, def func underscore with underscore timing, parentheses, column, new line, set the start underscore time, equal time dot time, parentheses, new line, print, parentheses, start underscore time, new line, call the function, result equal func, parentheses, new line, set then time and underscore time equal time dot time, parentheses, new line, print, parentheses, and underscore time, new line, calculate the duration equal and underscore time minus start underscore time, new line. Let's print something explanatory, print, parentheses, f double quotation marks, function, quotation mark, curly brackets, func that double underscore name double underscore, close the bracket, quotation mark, executed in curly brackets, duration column dot 8f. Close the curly brackets, seconds. And then we have to return the result. And then we have to return the returned result calling the function. So return func underscore with underscore timing. The way to decorate a function is to write the decorator on the line before the function declaration, prefixed with that symbol. So at time underscore it. And let's run it. And as you can see, we obtain the time of the execution of this function. So every time we call a function that has been decorated, it's like we are calling the decorator's returned function, which may internally call the original function or perform additional behavior. Now, what if we want to pass an argument to the function? Let's try it. Let's copy this call, change the name, and pass an argument to it. Let's say 200,000. Let's copy the function and paste, change the name, and we need to modify the nested function to accept the arguments as well. So let's add asterisk args. In this way we can pass as many arguments as we want. Also here, asterisk args. And now let's run it. It works again. We already saw the asterisk args in the beginning tutorial, and it's a typical way to pass an unknown number of arguments. But what if we want to pass k-value arguments? Let's try to do it. Let's copy this line, change the name, change the argument, and now add two k-value arguments, comma, threshold equal 100, comma, offset equal 10. Let's copy the function, change the name, none, comma, double asterisk options. In this way we can access the k values we pass from the resulted options dictionary. Let's modify the list comprehension. If options square brackets quotation mark threshold bigger than x and x module options square brackets quotation mark offset double equal 0. We have also to pass the argument to the nested function, so comma double asterisk quarks, comma double asterisk quarks, and run it. And as you can see, we created a generalized decorator able to take no arguments, one or more arguments, and a dictionary with an unlimited number of k-value arguments. Now let's recap. Lesson 02 hyphen decorator. We learn about decorator. We learn about the @ symbol to call a decorator. And we learn how to use the double asterisk and the common notation quarks and args. So for this lesson it's enough. Thanks for watching and see you in the next lesson.